Hello everyone, welcome to the new session of this unit, that is nothing but semiconductor material. Now in this session we are going to discuss the next part of this unit, that is nothing but diffusion, Hall effect and electrical and thermal conductivity of semiconducting materials. So let's start with the definition of diffusion. Diffusion is the movement of molecules from a region of higher concentration to a region of lower concentration down the concentration gradient. It is the most important process as we consider the semiconducting material fabrication processes. When the semiconducting materials has been formed, in that the impurity material it is to be added to the purest form of material, that process is to be called as the diffusion. Now what is mean by the diffusion? The diffusion is the process of movement of molecules under a concentration gradient. It is an important process occurring in all living beings. The diffusion helps in the movement of substances in and out of the cells. The molecules move from a region of higher concentration to a region of lower concentration until the concentration becomes equal throughout. Is called as diffusion. Let's take one example regarding with the diffusion. Now, as we consider the water molecule with the dye molecule, as shown in the figure 1, we should be having the process of diffusion with these two materials. In this example, take water in a beaker, add a few copper sulfate crystals at one place and leave it as it is for some time without disturbing it. After some time, we can see that the beaker contains a uniformly colored solution. Here, both the water and copper surfaces diffuse independently. With this experiment, we can infer that solutes move from a higher concentration to the lower concentration in a solution, and because of that we can get an equilibrium condition with the diffusion process. So in a pure water molecules, when we can add or dye molecules in that one, the process should be called as a diffusion. In the same example, the water which is in a purest form, it should be added with the dye molecules of copper sulfate and it becomes an equilibrium property with the materials. Now the most important part is nothing but the types of diffusion considered in various branches. The diffusion is widely used in various fields such as biology, physics, chemistry, etc. The diffusion can be classified into two main types, that is a simple diffusion and facilitated diffusion. In a simple diffusion, a process in which the substance moves through a semi-permeable membrane or in a solution without any help from a transport protein. For example, the bacteria deliver small nutrients, water, oxygen into cryptoplasma through the simple diffusion process. In this diagram, the facilitated diffusion we have to be considered. In facilitated diffusion is a passive movement of molecules across the cell membrane from the region of higher concentration to the region of lower concentration by means of carrier molecules. The process of that facilitated molecules or diffusion is carried out with dialysis process. The next one that is nothing but the osmosis, where the solvent molecules from the region of lower concentration to the region of higher concentration through a semi-permeable membrane, it should be occurs. Since water is a solvent in every living being, biologists define osmosis as the diffusion of water across selectively permeable membrane. For example, plants take water and minerals from the roots with the help of osmosis. Now the factors affecting this diffusion process are nothing but temperature, area of interaction, size of the particle, and the stiffness of the concentration gradient. The examples of this diffusion process is nothing but tea bag immersed in a cup of hot water will diffuse into the water and change its color, or a spray of perfume or a room freshener will get diffused into the air by which we can sense the odor. The sugar gets dissolved evenly and sweetens the water without having stirred it. As we light the incense sticks, its smoke gets diffused into the air and spreads throughout the room. By adding the boiling water into the dried noodles, the water diffuses, causing rehydration and making dried noodles plumper and saturated. Causes of diffusion. The diffusion is natural and physical process which happens on its own without stirring or shaking the solution. The liquid and gases undergo diffusion as the molecules are able to move randomly. The molecules collide with each other and change the direction. These are some significance of a diffusion. The diffusion is an important process which is involved in a different life processes. As mentioned above, it is the net movement of particles, ions, molecules, solution, etc. In all living species, the diffusion plays an important role in the movement of molecules during the metabolic process in the cells, because during the process of respiration, this process helps in diffusing the carbon dioxide gas out through the cell membrane into the blood. Diffusion also occurs in the plant cells. In all green plants, water present in the soil diffuses into the plants through their root hair cells. The movement of ions across the neurons that generates the electrical charge is due to the diffusion. Now the next concept regarding with this unit is nothing but the Hall effect sensor. The Hall effect sensor is used to identify or to check when there are two magnetic fields are acting on a simple surface. The Hall effect sensor is used to identify the affection of two magnetic and electrical fields with each other. Over here the diagram of that Hall effect sensor. As we see in this diagram, the simple electrical conducting plate, it is to be placed with the help of a DC power supply. Conducting, the DC current flows through it. The constant current flow, that is DC current, it should be flows with the help of the power supply, which should be available according to the DC power source. Now, for the same plate, we can apply the magnetic force on that plate. What will be happens? The current which is flows normally in the direction of horizontally, it should be affected by the magnetizing force which should be applicable to the conducting plate. When the magnetic field and electrical field is combined together, or it should becomes in a contact with each other, then due to the magnetic field, the current is to be distracted according to the magnetic flux density. When higher magnetic field, it should becomes in the contact of this conducting plate, then the current flowing through that conducting plate, it should be distracted. Now the angle of this distraction is directly proportional to how much magnetic force we have to be applied on that conducting plate. Due to that, we can take an whole voltage, that is nothing but the change in current which should be produces with the help of electrical and magnetic field, or otherwise the distraction of that current which should be directly proportional to the applied magnetizing force. When we can apply a large magnetic force on this conducting plate while the conducting plate is having its own DC current, then the distraction of that DC current is directly proportional to how much magnetic field we have to be applied on this conducting plate. This is how the Hall effect sensor, it is to be used to identify the distraction of that current due to the magnetic field. The application of such type of sensors are nothing but the applications where two different types of fields are to be used, that is magnetic field and electrical field. Let's check the description regarding that one. The figure shows the principle of working of Hall effect sensor. The Hall effect sensor work on the principle that when a beam of charged particles passes through a magnetic field, forces and act on the particles, and the current beam is deflected from its straight line path. Thus, one side of the disk will become negatively charged and the other side will be of positive charge. This charge separation generates a potential difference, which is measure of distance of magnetic field from the disk carrying current. This is how the Hall effect sensor should work. Now the next point is that the thermal conductivity of semiconductor. In that one, the heat conduction usually occurs in two different ways. The first one, that is nothing but by the electrons, which is generally we can call as electrical conductivity, and the second one, that is by the thermal vibration of atoms should be called as random thermal vibrations of the atoms in a semiconductor. Now it may be regarded as the sum of the total vibrations of individual atoms. That should be nothing but the atoms in pairs considered as a body as a whole. The total conducting material should be having the thermal vibrations. We should be carrying the thermal energy with the help of vibrations into that conducting material. The higher the temperature, the greater are these vibrations. If we increase the temperature applying on that conducting plate, then that vibrations are also hit at higher levels. The coefficient of thermal conductivity of a semiconductor has two parts. That is nothing but the thermal conduction due to the electrons and the thermal conduction due to the thermal vibration of atoms. Now, when the concentration of free electrons in the semiconductor, it should be varies. The thermal conductivity due to electrons also goes on varies. It direct proportional to the electrical conductivity, whereas thermal conductivity due to the vibrations remains practically constant. The Weightman law for metal is K upon sigma is equal to AMT, where AM is the constant for all metals. This law can be applied to the semiconductors and states that K is equal to AST sigma plus KLH, where AS is the constant of corresponding semiconductor and KLH is the contribution to the thermal conductivity due to the vibration. Now the next point is nothing but the electrical conductivity of doped material. As we already discussed this point in a previous session, a semiconductor may be doped with donors and acceptors in which case the density of one type of carriers predominates. Thus, in the presence of donor levels, the electrons are majority carriers, and the presence of acceptor levels, holes, are the majority carriers. The free carrier concentration given by the impurity atoms whose valence electrons have energy less than by delta E, then their energy is free state. That should be given by the equation N is equal to A1E raised to the delta E upon 2 kT. The valence band is also always contains a certain number of holes. It may be shown that the electrons and holes concentration are related as NeNH is equal to Ni2, where Ni is equal to E raised to minus delta E upon 2 kT is the concentration of either electrons or holes when impurities are added and delta is equal to forbidden energy gap. The electrical conductivity of doped material should be depends upon the holes and electrons carriers into semiconducting material. In the presence of donor levels, the electrons are majority carriers, while in the presence of acceptor levels, the holes are the majority carriers. The free carrier concentration given by impurity atoms whose valence electrons have energy less than by delta E, that is nothing but a small change in that energy in a free state, is given by the equation Ne is equal to A1E minus delta E upon 2 kT, where the valence band also always contains a certain number of holes. Now, it may be shown that the electrons and holes which should be having the higher concentration E is nothing but the concentration of electrons and holes when no impurities are to be added in that one. As we know, the resistivity of intrinsic material is approximately given by the expression rho I is equal to AI e raised to delta E upon 2 kT. We identify that the type of material, that is either it should be conductor, insulator or semiconductor, with the same equation. For example, the substance for which the energy gap delta E is 100 or 200 times the value of kT will be an insulator. But if delta E is less than or equal to 1, that means about 40 times the value of kT, then it will be a semiconductor material. The graph of resistivity, that is nothing but rho I of an intrinsic semiconductor plotted against 1 upon T on a semi-log paper will be a straight line. It is then possible to obtain the value of energy gap delta E by measuring the slope of this graph. The product of two concentrations doesn't depend upon the number of impurity atoms nor on electron energies of such atoms. It always equals to the square of free electrons or the hole's concentration of pure semiconductor at that temperature. Now, in general, we can say that the impurity type of semiconductor, if we increase the conductivity at low temperatures, it is smaller than that for an intrinsic semiconductor. But at higher temperatures, the behavior of impurity type semiconductors is very similar to that of the intrinsic types. At the medium values of temperatures, through the conductivity of impurity type semiconductors decreases to some extent depending on the percentage of added impurity. The behavior of similar to that of metals. This happens due to the reduction takes place in the mobility of electrons on holes. Now, as we know, if we can plot the resistivity versus temperature block, then the various curves corresponds to the maximum amount of impurity concentration when the substance is least pure, whereas it corresponds to minimum amount of impurity with concentration That means when the substance is mostly pure. So this is how the temperature it should be affects the conductivity of particular material. So up to this part we can conclude over here. The remaining part we will discuss in next lecture. Okay, thank you.